Hey everybody, Bill Sky, the C++ guy, and this is another advanced C++ video, and what we're going to do is we're going to talk about constructors and destructors. Now, if you haven't watched the Introduction to Object-Oriented Programming in C++, or if you haven't watched the class member video, I suggest you go back and watch those. In fact, in the description of this video, there should be a link for allowing you to go backwards. However, if you've got some knowledge of that and you just want this as a refresher, then I think you're okay by just watching. So, first of all, in the Introduction to Object-Oriented Programming video, we talked about the very basic things about a constructor and a destructor. A constructor is what is executed. It's a function that is executed the moment that an object is created, either a static object or a dynamic object using the new keyword. A destructor function is a function that executes right before the object is completely removed and deleted, and you're not allowed to use it anymore in your program. And this happens when the program ends, if it is a static object, or when you use the delete keyword, if it's a dynamically allocated object. However, there's more to it than just that. You can have non-default constructors. You can have constructors that have one parameter you send to it, multiple, and that's what we're going to look at today. So let's get started. So I've got my project here that I did in the member video, where I created a building class and I created my main CPP file that actually calls that class. And I'm going to go ahead and run this, and really all this does is it allows me to enter in some data as a user, and I let the set number of floors and I let the set average floor square feet functions within the building class decide whether or not I entered in some valid data. So, and we can take a quick look at that. So let's go ahead and build that and run it, and you can kind of see how it works. So some of the conditions are you can't have negative numbers of floors, and it returns a Boolean if it set it correctly. A true if it set it correctly, it returns a false if it didn't. So we're letting the class decide if the data is valid. So I'm going to say 10 floors. And now it says, please enter the square feet of each floor. I'm going to say minus 900. The class said, wait a minute, negative square footage is not good. So I'm going to say 500 square feet, and it lets me go ahead and set it. So that's really all it does. And then there's a while loop for each one of these that allows me to keep asking the same question until the user types in a valid value based on what the class says the valid value should be. So that's really all that we've done here. Now, let's take a look at the way that we constructed our building variable. Here's an example of a building variable that simply says building 101. That is what we call a static. This is a statically allocated building variable. That means that that variable will be created every time this program runs, whether or not you need it. And then you could also create another one, except instead of a static, you could create a building pointer. And in this line of code, what we're doing is we're creating a pointer to a building, and the name of that pointer variable is building 201, but we haven't actually created the object yet. To actually create the object, we have to say building 201 equals new building. And then you specify the parentheses at the end, and you have to spell it right first. So at this point, this is when the constructor will be executed, not at this point. With a static object, the constructor is executed the moment that the building object is actually created statically. Now, when will the destructor be executed? Well, the moment I say delete building 201, the destructor will be executed for that. However, I cannot say delete building 101 because building 101 is a statically allocated object, and you can't delete a statically allocated object. So when is that destructor actually executed? It is executed the moment the main function returns 0 and it's actually unloaded from memory, then the C++ runtime environment will delete that or execute that destructor to clean it up. So that's just a little review of what we did in the Introduction to Object-Oriented Programming. So let's get rid of this pointer and let's just stick with statically allocated objects. So I'm going to create another object, except what I would like to do in this case is instead of just setting up the building with default values, which by the way we haven't done yet, so let's do that. So I'm going to go into the default constructor. Now what makes this a default constructor? It has the same name as the class, in this case building, and nothing in the parentheses. That's what I call the default constructor. And every class should have one. I've never worked for a company that didn't require me to specify the default constructor. There might be reasons that you don't want to do it. I've never experienced those, but I can understand why you might want to do it. And what does a default constructor normally do? A default constructor normally sets everything to 0. So we're going to just set everything to 0. And it's kind of nice because you now have a single function. Every time you load up your class or you create an object of your type class building in this case, everything will be set to 0. And you could actually debug this if I build this and then I click the debug. Well, let's put a breakpoint. So I'm going to put a breakpoint right here on the, actually it'll create it on the main. So let's go ahead and debug it. I'm going to click the little debug symbol. I'm going to open up the debug perspective. And I'm going to do step overs until I actually get to here. So now when I actually allocate the building, if I click step into, it takes me to the building constructor and it defaults all of the building's attributes, all of its member variables to 0. And so really, really nice. It's a really nice way of initializing everything. I'm just going to stop and go back to my code. So that's an example of a constructor being debugged. And that is a default constructor. Now you're allowed to have other constructors. Let's say you want to send the number of floors to the building when you create it. And you want to set that data without having to do it separately. Why would you want to do that? Well, you kind of have to do this. When you create a function or when you create an object, you have to say building, in this case, building 101 dot set average floors is 0. Actually, let's say set average floor square feet 1,000. So you have to go through number of floors 20. So you have to write a lot of that code. You have to say, I want to set every attribute. Now, I use setters here because all of those variable attributes are private. But let's say I would like to do something like this. Let's say I would like to say building, and I'm going to use a different building here, building 201. And in parentheses, I would like to say, well, the square foot is 1,000. The number of floors is 20. I would like to do that in a single line of code. Now, right now, that will not compile because we don't have that non-default constructor set up. So let's go in and set up that non-default constructor. And what I'm going to do is I'm just going to copy and paste the default constructor. And it's going to take 2 arguments. And let's not make this the total square feet. Let's make this the average square feet. So let's say the average square feet of each floor is 20,000. So we're going to send it the average square feet and the number of floors when the object is constructed. So what we're going to do is we're going to say double average square feet, and we're going to say integer total floors. So now we have defined a non-default constructor, and what makes it a non-default constructor is that it takes arguments. There's arguments inside the parentheses. If you notice in our default constructor, there's nothing in those parentheses. Now we still have an error here. If I try to build this, we still have an error because we didn't change it in the HPP file. So what I'm going to do is I'm just going to copy that code into the HPP file. And now we have our non-default constructor. So if I save it and build it, it should build okay. Now it looks like we still have a problem in our main, but that's okay. And we're not actually done with this yet. I'm going to get rid of this to-do. Eclipse has this thing called to-dos where you can manage, remind yourself that you need to do some code, or there might be a problem in the code that you need to debug. So what I'm going to do is I'm going to say I'm sending the average square feet in the total floors. So instead of making it 0, I'm going to say AVG square feet. Instead of 0 for number of floors, I'm going to say total floors. And so now when you create a object of type building using this syntax, you're actually constructing the data as it's being created. Okay, let's go ahead and build this. It looks good. All right, so let's debug this and see what happens now. So I'm going to go click the debug button. I'm going to step over. We know what happens with the default constructor. Notice there's no parentheses at the end there. So that's going to always call the default constructor, the first one. I'm going to step over. Now I'm going to step into, and let's see where this goes. So notice this goes to the non-default constructor. So it's going to set the average square feet, the total floor, and it's going to set temp double, total square footage, and then it's going to leave, and then the program is going to continue. So you can see that because we actually constructed, or we defined building 201 with parentheses and 2 variables or 2 values inside, it didn't go after the default constructor. Now there's a little bit of a problem here. It's not a huge problem, but it's one that I really don't like, and I've got some repeating code here. So I've got 2 lines of code that are actually done in here. So what if I wanted to default that to 100 and I was defaulting it here to 0? I've got some inconsistencies there. Why did I default it to 0 here and 100 there? So when you've got duplicated code, you can actually open up possibilities of problems. So C++ has a way around that. Instead of reproducing this code, I'm going to delete it. And I do want it to be 0, but I was just doing that as an example. I'm going to delete it, and right after my non-default constructor, I'm going to put a colon and say building. What that's going to allow me to do is that's going to allow the program, when it executes a non-default constructor, it's first of all going to execute the default constructor by simply putting a colon and the default constructor. So now let's take a look at what happens. So let's build that. Okay, it looks good. Let's debug it. Okay, I'm going to step over. Now I'm going to step into, let's watch what happens. Now remember, the last time we did this, it went into the non-default constructor, and we had to hard code those values. Let's see what happens now. Step into, notice what it did. Because we put that colon building at the end, it is now going to execute the non-default constructor first, set up all of our variables to what their initial value should be, and then when it's done with that, it's going to go back in and set them to what we sent the non-default constructor. So that's actually a really nice little feature about C++ object-oriented coding, is that you can have one constructor call another. Now, one thing that I've always done in my career is I've always created a function, a public function called, it doesn't even have to be a public function, it could be a private function. So I'm going to come down here, there's that silly function called stand. I'm going to create a function called initAll. And what initAll is going to do is it's just going to do all that initialization for me. So I'm going to go into building CPP, I'm going to implement initAll, and you want it to be the same, so I'm going to put a void there. And I'm going to take these lines of code in my default constructor, I'm going to place them in my initAll, and in my default constructor, instead of setting all those there, I'm going to just simply call this dot init all. And now, instead of doing this, I can just say this dot init all. So in all of my constructors, however many I have, I can use that this init all. And then I don't need this any longer. Now I believe the reason that I've always coded this way is because back when C++ first came out, we didn't have the ability to do this. To do building. We didn't have that ability. The compiler didn't have that ability to do that. So what we would do is we would always create a function that looks something like this to initialize all of the values. One nice thing about this is that we always know where the initial values are defined. They're not defined in multiple different places in your code. All of your constructors do this. And if you make this function public, you could also allow the programmer using your class to initialize the values in the object anytime they want. So it's actually a really nice way of coding, and it's solved a bunch of problems for me in the past. So you're not required to do that. And this is not a constructor. Why is this not a constructor? Because the name of the function, the name of the method is not the same as the class. So it's not a constructor. It's simply a function that I am using in place of my constructor that my constructor will call. Okay, so that is our non-default constructor. Now, the other question is, how many of these can I have? Well, you can have as many as you want. One thing that we haven't done here is that I actually do not have an attribute called building name. So I'm going to create a string called building name. And I haven't actually created the getters or setters for this. And also we have an error here. It doesn't know what string is. So we have to come up here and we have to say pound include string. I'm going to say using namespace std just so we don't have to code a bunch of stuff. And there we go. So I haven't actually created the getters and setters for that. So I'm going to say source generate getters and setters. Oops. So let's go ahead and do this. Source generate getters and setters. There's the building name. I'm not going to do temp double. That was a private variable, so I'm not going to do that. I'm going to say definition separate and OK. And this is something that Eclipse does for us. It isn't anything that, not everyone does that. Okay, so I always like my setters to return a Boolean. And then I have to go back into building CPP. And I'm going to have it return a Boolean. Now for a string, what would I do for a Boolean? What would I do to validate it? I would say if building name dot length is equal to 0. I don't want to have a blank building name. Return false. Else. Return true. Okay, so you don't want to have a blank name in your class, or in your string, I should say. All right, so why did I do that? Because I would like to create another non-default constructor that takes a string. So let's do that. So I'm going to create another non-default constructor, and what I'm going to do is I'm just going to copy this non-default constructor, and instead of this, I'm just going to say string the name. I'm going to go ahead and call the init all function, and that's going to initialize all of my variables to blank. Also, notice I know exactly where, since I added a new attribute, which is the name of the building, I know exactly where it is. It's in one place, and it's in my init all function. So I'm going to say this dot building name equals, I'm just going to say unknown. Let's make the building name unknown by default. So my non-default constructor that takes a string, I'm going to call the init all, and then I'm going to say this dot building name equals the name. And so now we have a function, another non-default constructor that takes just a string. Now I'm going to copy this because it's not going to compile, because there is nothing in the building class called building with a string. So I have to go into here and I have to say, put that prototype in there. And you want to get rid of the class name : in your HPP file. All right, so let's build that and see how it works. Everything looked good. I'm going to go into my main, and this time I'm going to create another building. And this time I'm going to put in a string called, I don't know, research. Building 202. And let's save and build that, and let's debug it. I love debugging. You guys are so lucky to have debuggers. Back when I was coding, we didn't have debuggers. They would just print us off a big stack of paper, and we'd have to go through and look at the machine code. Ugh. So let's go in there and click the debugger. All right, so we're going to do a step over. We don't care about that building. We don't care about that building. But now we care about how that building is constructed. So we're going to step into... Oh my, what is going on here? Okay, so let's go ahead and stop. This is one of the little caveats with debugging. So let's go ahead and start the debugging again. Step over, step over, step over. Okay, now there's something going on here with this C string. Remember, a double quoted string is not really a string in C++, it's a C string. So what we might have done is by clicking step into, we might have entered some of the source code for the C++ library that converts a C string to a string. So what I'm going to do is I'm going to go into the building CPP, and I'm going to put a breakpoint right here on the string building non-default constructor that we did. And then I'm going to click the continue button. And so now we've avoided all that extraneous stuff that we're not interested in, and we're actually in our non-default constructor that takes a string. So what this is going to do is first of all, it's going to call the init_all function. I'm going to click step into, and I clicked step out of, so it didn't actually take me in here. I could expand this over here in the debugger, and we can see that all the values were initialized. And that was done by calling this. Okay, so now we're going to step over. We're going to set the name. There it is, research building. Something new in the debugger I don't think I've ever shown you. And that's how to look at the actual values of the object in memory. And then we're back to our main. So those are default constructors and non-default constructors. I can do another one. I can go in and say, okay, I would like to do one that has the string as well as the number of floors. So I'm going to say int num floors, init_all, set the name, this dot number of floors equals num floors. And again, this hasn't been defined yet in the HPP file, so we're going to have to go into the HPP file, put that in there without the building : Now I can go in here. Oh, did I change what it did? Yep, I changed the number of floors. So now I'm going to go into here and I'm going to say building 203. This is the manufacturing, building 203, and it has 6 floors in it. Let's go ahead and save and build that. Go back to the C++ perspective. Let's debug it. Step over, step over, step over, step over. There we go. So now we're in the init_all. So I'm going to step into. You can see we're now in the init_all function, so we're going to go ahead and set all those values, initial values. I can come over here and look at those initial values in my object. I'm going to click step over. The building name is being set. Okay, now we're on, that was the previous one. Now we're on the one that takes the building name and the square footage. I'm going to click step over. Actually, let's go back into there and let's put a breakpoint on the init_all right there. That's our new non-default constructor. And now we're in it, so I can click step into. You can see init all is being executed. Now it sets the name to manufacturing, the number of floors. It's going to set it to 6. All right, great. So let's talk about one other thing here when it comes to default constructors. In a non-default constructor, you're assuming that the programmer is sending you valid data. Now, remember, in our getters and setters, we returned a Boolean. And the Boolean would look at the value that was sent to it, right? The function would look at the value set to it, and it would either set it or it would not set it based on the conditions that you gave it. Remember, we called this information hiding and data validation or data protection. Well, in our non-default constructors, we're not doing any of that. Now, so you've got a couple of options here. You can reproduce this code in your non-default constructors, or even better, what you could do is, instead of doing this, you could say this dot set average floor square feet. You could actually call the functions that do that work. Number of floors is the same thing. This dot set number of floors, and that was total floors. So you're letting functions that you've already written that validate the data, you're letting those functions handle whether or not the data is correct. Now there is one little caveat here, is that non-default constructors do not return anything. I cannot do this. I cannot say bool building. Let's go in there. Let's actually try it. So this was bool. This takes a double and an integer. So where's our double and integer? There it is. If I try to say that this is going to return a bool, I get compiler errors. Constructors of any type or destructors, they cannot return any type of data. So they always return void. In fact, you can't even say that they return void. That's how persnickety the compiler is. So you've got no choice there. So what could you do? What could you do if you're going to be calling your functions, your setter functions from within your class? Well, what you could do is you could create a private variable. I don't know, we could make that a char, or we could make it a Boolean, and we could call this class status. And class status would be true if it's okay, false if it's not okay. So I'm going to go back into my default constructor here, and I'm going to say if that's true, then I'm going to say if that's true, I'm going to say class status equals true. Class status equals false. And there's probably a better way to code this. And actually, I'm not using this at all here. I really like using this because it just is kind of like self-documenting. So as I said, there's probably a better way of coding this. So if either one of these returns false, it's going to set the class status equal to false. If both of them set the data correctly, the class status is going to be equal to true. Well, what good is that? Well, what you can do is, I'm going to take this class status and I'm going to create the getters, and I'm just going to create the getter for it, because I don't want to be able to set it from outside of the main. I want the class itself to manage its own status. So I'm going to generate getters and setters. Here's class status. I'm just going to click is class status. And here's is class status. All it's going to do is return the class status, true or false. So how can I now use this? After I do this, I can say if building 203 dot is class status, tout building 203 was created successfully. Excuse my spelling, else building 203 was not created successfully. So by doing that, you can actually check in your main, is that object okay? Now I'm going to go ahead and just run this and see what we get. Okay, it was not created successfully. Oh my, why was it not created successfully? Let me see, we have 203 and 6. Let's see what the code, let's debug it. I love debugging. So let's debug it and find out. I thought it was created successfully because we have a string and the number 6. So let's step over, step over, step over, step over. Okay, so now we're in the name, so we're going to knit all. I'm just going to go through that. Oh, it doesn't look like we actually captured. It doesn't look like we captured that in there. We captured it up here in this one. So that's why it didn't work out. So I'm going to go back here. So we are going to have to change this code over here. And you have to change it for all of your code, but that's okay. The other thing you could do is you could just default the class status to be true before you ask any of these questions, before you set any of them, and then just let it set it to false. Actually, let's do it that way. I'm going to say class, or this dot-class status equals true. And I'm going to say if not, this is negative logic. I'm going to say this dot-class status equals false. If not, so the code's a little bit smaller. So that one will set the class status. Let's make sure I coded that right. Oh, I've got some problems here. What did I forget to do? Oh, we don't have a close. Actually, we do. What did I do wrong here? Oh, I know what I did wrong. I didn't. So let's go back in time here. So I think I was looking at the wrong code. Okay, so this isn't actually calling the functions. That's what that's doing. That's what I messed up here. So I'm going to say this dot set building name, and that was the name. This dot set number of floors, and that was num floors. All right, great. So now we can go in there and say if this dot class status equals false, and we have to make sure we use negative logic there. If not, this dot set number of floors and I'm just going to copy this. Okay, so now we've got, and if you look at the difference between these two, the code is much smaller down here. It's not necessarily more complete because we don't have the else statements there, but let's see how this works. So I believe this will now work, so let's go ahead and just run it. Ah, it was still not created successfully. Oh my goodness. So let me see, that was for 203, that was taking a string, and so we gotta go and debug it again. Good practice. Okay, so we initialize everything to nulls. If this, that's interesting. So what have we done wrong here? It looked like it did it right. Let's take a look. Oh, I never set it. Oh, this is another good example. I never set the status to true. And so what's really nice is I can do that down in the init all. this dot class status equals true. So now when I can call init all, it'll set it equal to true. Now we say it was created successfully. So now our code is correct for creating things if we do it correctly. Let's now do it incorrectly. So I'm going to put a -6. And it should not create it successfully. It was not created successfully. So at any time, you can, by using this whole idea of a class status, if there's any bad data in the class, you can tell by simply querying that class status. And in this case, Eclipse called it isClassStatus. You might want to change that variable name to, a class, isClassOK. Class OK might be your variable name instead. So those are default constructors, non-default constructors. As I've said in this video, you can have as many of those as you want. Now, you really can't have as many as you want, but you can have as many as the argument list is unique. So in other words, on line 17, we have a building constructor that takes a double and an integer. You cannot have another building constructor that takes a double and an integer. You can have one that takes an integer and then a double, but they can't be in the same order. So there definitely are some limitations to that. Now, what about the destructor? Well, you cannot have multiple destructors. There is only one destructor per class. So that makes it easy. Destructors can never take arguments either. You can never send arguments to a destructor. And destructors are really, really simple. Really, the only purpose for a destructor is to clean up any data. Maybe you've got some confidential data. Maybe you might want to say number of floors. You want to set everything to 0. So that's one purpose of a destructor, is to reset everything to 0. And you might say to yourself, well, why go through all this trouble? Well, what if you have a class that has somebody's password in there? And when the program is done, the destructor did not clear out all of that memory. It didn't set everything to 0. It didn't blank out the password. So you now have a password somewhere in memory. Windows, Linux, Mac, they're not going to clean that memory for you. And that's called a security problem. You have a security issue with your program. So it's a good idea to zero out or space out all of your data in that object in the destructor. The other thing is that if your destructor or if your class contains a pointer to a variable that you allocated in the class, you may want to do it here. So for instance, let's say that I have a private variable, and this is going to be completely useless, but I'm going to have an integer pointer called an int ptr. And in your init all, you say int ptr equals new int with a value of 0. Well, where are you going to delete that pointer? And I think let's make sure I got it right. Oh, it's an int pointer. So let's copy that. Okay, so because it's private, you on the outside don't have the access to delete that, and you don't want to have a memory leak. So this is a perfect place to delete it, is in the destructor. So I'm going to say delete this dot and int pointer. So you want to make sure that you clean up stuff you use the destructor to clean up stuff in your class, and you can only have one destructor. It can help to zero out values. Let's say if you had somebody's bank account information in memory, you don't want to keep that in memory. You want to zero it out, and that's one useful thing for the destructor. So that's an overview of constructors, default constructors, constructors, default constructors, non-default constructors, destructors. Also the ability to call a function from within a constructor, or call it at the end of the function definition with that colon and then a function name. And that's a good introduction to constructors and destructors. It's very, very flexible. I use them all the time. I hope you do too. Practice, practice makes perfect. See you at the next video.